Hi guys, welcome back to the shop and hello to any new viewers. Now today what we're going to look at is the very glamorous topic of joining wires together for the purpose of making electrical connections. We'll be dealing with low voltage stuff, which is car, trailer, small machinery, home electronics, stuff like that, and we'll leave the high voltage wiring to the electricians in your house or whatever. Now, being able to join wires, more than likely you'll come across that at some point where you have to swap a component out of a car, be it a light, a switch, something like that. And being able to join wires is just one of those life skills which is very handy to have. In addition to being able to join the wires, we must be able to do it properly, and we'll do that by using proper connectors, the proper strength of wire. And a good point to note is that if you are swapping wires or replacing wires, you swap it like for like, because the wire is designed to be of a particular size, a particular resistance in a particular function. So very important not to use a smaller wire where there was a bigger wire before, etc, etc. So what we'll look at is the various methods of joining wires, and we'll also keep an eye on being able to join different sizes of wires, because of late I've noticed that a lot of replacement lights are now LEDs. They're operating, or they're utilizing much lower wattage, and therefore they're using much smaller wires as a sort of a tail on them, which you need to link into a bigger wire then. So some of the more traditional styles of wire connection mightn't be applicable when you're trying to join a big wire with a small wire. Okay, we'll just go through the various types now and give sort of pros and cons of each of them. Now, first up on our list here, and we set up a sort of an overhead type of shot down, are the old style strip connectors. Fairly straightforward. There's two screws on top, there's a sort of a brass or a copper fitting inside, which you screw the wires down into, and effectively then they clamp them together. They come in a range of different sizes, big to small. This one I think is 380 volts or 30 amp or something like that. Obviously the smaller ones then would have a smaller capacity. These have been used for years. They provide a good solution. The downside with them, or the two downsides with them, is number one, they're not particularly weatherproofed. They allow moisture into the back of the cables. And the second issue with them then is either under tightening or over tightening, or not making a good connection inside in the barrel of the connector. But if you take a bit of care, they can work away fine. So basically the way they work is, we get a piece of wire, strip it, give it one small loop just to tidy up the wires. Now, very important that when you are putting these in is that you make sure that all the connectors go in and that they're making a good connection effectively with the screw down terminal. So after we have our wire in there, just screw it down with the screwdriver, give it a good firm tighten, but just don't go mad on it, and that will give you a good connection then. So it is possible to use these inside an enclosure box, and they're fine and weatherproof at that point. Okay, so that strip connectors have been serving industry for many years. Nothing wrong with them, but there are just easier ways to connect wires inside in a very small area, especially if you're working inside in a vehicle. And as I said, the issue with them is weatherproofing and a lack of correct tension on screws, either through over tightening and damaging the connector, or not having them tight enough and then they vibrating out then over time. Now, our next style of making a wire connection is with Wago style connectors. Basically what these are is a little clip system whereby you strip the wire, you put it into the receptacle here, and then close down the little spring loaded mechanism, and it clamps the wire. And if we look at the back of the connector there, what we can see is a little metal bus bar, and the spring mechanisms clamp the wires down onto that bus bar inside, and that's what makes your connection for you. Now, there's a number of different types and styles of these Wago connectors. These are sort of one of the most common. What they are is 221412. Okay. On the box, you can see that they cope with stranded wire, solid wire, and then fine stranded wire, and that runs in a range of sizes from 0.14 millimeter up to 4 millimeters. So what we're looking at there is a fantastic piece of capability as regards joining a big wire to a small wire, because you have such flexibility within the connector itself. One of the great advantages with these as well is that they have the information probably on the side of them as well. There is there in tiny little writing just here the length of the wire that you should expose for the purposes of making a good connection. So I have my wire stripper set up to about 10 mil thereabouts. This one requires, geez, I can't even see it, it's either 11 or 13. But if we hold our wire there, you can see there that it matches up with the guide. And when we put the wire in, we can actually see it going in there. We don't put the insulation into the connector ever. The wire should bottom out at the back of the Wago connector. We close our little spring, and then what we can see is our wire is actually clamped down inside there. And the same on the far side then. Obviously you wouldn't be putting a short together like this, but just for the purpose of principle, in, close, and what we have there is a very, very secure connection, and you can see it there. There is also on these as well a little point, a little hole somewhere where you can actually run a test probe into them and check it for voltage, continuity, etc., without actually having to open the connector. So that's Wago style connectors. These ones here are, that one, the small one there is a 221412. The slightly bigger one is a 221612, and the 221 bracket is for, sorry, the 2 at the end is for 2 sections to clamp. If that was a 413, there'd be 3 sections. 415 would be 5 sections, so on and so forth. And then the 4 here at the start indicates the maximum wire size that you could put into it. So this one here, the 221412, has a maximum wire size of 4 mil, and then the 612 has a maximum wire size of 6 mil, but it doesn't go quite as low as the 4 series. I think it's 0.5 mil up thereabouts. So these are particularly a versatile tool. You can get them into particularly anywhere, any tight confined space. They clamp a range of different sizes. The weatherproofing is so-so. The majority of it is shielded. You're only open at the back, and there's a good surface area clamped onto the bus bar, so theoretically you should have a decent bit of weatherproofing, but just not perfect. Okay, so that's Wago style clips. And before we move on from the Wagos, I've seen a lot of YouTube videos out there as regards Wago connectors versus wire nuts. Here in Ireland, we just don't see wire nuts at all. I wouldn't even know where to get them other than online if I actually wanted to find some. Our historical methods of connection are either with the strip connectors or more recently with the Wago style clips. Okay. Now, next up on our connector types are what are called crimped connectors. And effectively what they are, and they come in a range of sizes obviously, is a little hole at the back here of the connector, and this is a butt style, so 2 pieces of wire butted up against each other effectively. And then what happens then is you take a crimping tool like this, and it goes in there, and then you squash down the connector onto the wire, and that performs a crimped connection. They come in a range of sizes. I got a set with red, blue, yellow, and effectively the way that sort of pans out is red is for small wire, blue is for medium, and then the yellow is for much bigger wire. And if we hold up one of the yellow ones here, you'll be able to see that in comparison with the diameter of the red one there as well, that they are of a different size. What exact sizes they are, I'd probably have to look up. But from an automotive perspective, if you get a good crimp and the wire is secure in the crimped connection, it makes for a good connection. So we just demonstrate those now, and what I'll do is I'll actually demonstrate a method whereby we can join 2 different sizes of wire. So if we take a piece of wire, we'll say small gauge wire, and we stick that into our blue connector there. Now the way these operate is that the insulation should not go into the metal piece of the connector. The insulation should sit outside it. We look then at our crimping tool here, and we stick the crimping tool with the blue marking on the crimp or the crimp connection, and then what we do is we clamp it down. And don't be afraid to clamp this down good and hard. to make a good connection, and that then is a good secure connection. What we've done there is we've put a piece of sort of medium gauge wire. It's probably a bit long there now, and out on that side it doesn't need to be that long. We've made a good connection with the piece of medium gauge wire into a blue connector, and if we had a piece of very, very small wire, then what we could do is put that into a red spade or a female spade type connector, and then we could join the two of them together like that. And the way they operate is that there's a little dimple on one of the sides of the spade connectors, and it recesses then into the other side. So what we'd have there is medium sized wire connected into a blue connector into a small connector onto a smaller wire, and that gives us flexibility then. And as I said, obviously the wire should not, what do you call it, come out too far there into the point where it's interfering with the other connector. Right, that's crimped connectors. There are uninsulated or non-insulated crimped connectors as well, and we'll say if we look at this tool, what we can see there is the insulated ones fit into the top and they're color coded, and they're also numbered as well: 1.5, 2.5 mil, 4 mil and 6 mil. And then what we have down here is a different style of crimper for non-insulated crimped connections, and effectively what they are is basically these without the insulation on them. They come with two sets of wings. One set of wings is designed to clamp onto the wire, and then the set of wings behind them are designed to clamp onto the insulation of the wire and to close up the insulation to effectively weatherproof down the piece of wire. Okay, so that's crimp connections. Just some other types there in the range. You'll have these forked ones as well, whereby you can put a bolt or a screw through that and clamp that onto a connection board. Same with the ring types, bolt through there or some type of screw mechanism, and you'll see different types of clamping plates on some electrical components, whereby you could just slide one of these in, tighten it up, and that's your connection made in with your wire on the back of it. Okay. Now, next up on our list of connection capabilities, and I probably should have mentioned it in the last section there with the crimp style connectors. Generally they're used with what's called heat shrink tubing, and the way that works, I'll just give you a quick little demonstration. What it is sort of a plastic style tubing that when heat is applied to it, that it shrinks and it clamps or shrinks down onto a connection and effectively makes it waterproof. So if we were joining two pieces of wire, either with a crimped connection or a soldered connection, we'd slide a piece of heat shrink tubing on first. We'd join our two pieces of wire, and you use the smallest heat shrink connection that you can, because they only shrink so much, and then you apply a bit of heat to this, either with a hot air gun, possibly with a lighter as well, although you hold the lighter well away from it and only let gentle heat touch it, otherwise you'll actually set it on fire or melt it, as opposed to it performing its shrinking capabilities properly. And then that provides sort of a good bit more weather sealing, and you'll see them used a lot in automotive applications especially. So onto our last sort of methodology of joining wires, which is using a soldering iron and solder. And effectively what this is sort of, it's like metal gluing, for the want of a better description. One point to note is that when you are applying solder wire to a joint or a connection, the solder wire has to melt as a result of the connection itself being hot, not the soldering iron. This stuff cools so quickly that if we melted a bit with the soldering iron and just let it fall onto a connection, it has probably frozen before it meets that connection, and it'll just sit on top of it, and what you'll get then is what's called a cold solder, and it has no mechanical or very poor electrical connectivity to it as well. So that's soldering in a nutshell. Generally speaking, soldering wire melts around 220, 230 degrees centigrade. Soldering irons run 300, 350. I think this one runs at 400 degrees centigrade. So it should pump heat into whatever joint you're making. If you're joining wires, what you need is a chisel tip rather than a pointed tip. The pointed tips will be reserved generally for putting components on a board or much more precise and smaller solder joints. So what we'll do is we'll turn on our soldering iron and start letting that heat up. And as soon as it heats up, what we'll do is we'll tin the top. Very important to keep the tip of your soldering iron tinned. And we'll say soldering wire is a mixture of tin and traditionally lead, but the more recent ones now are much higher proportion of tin and then a few ingredients to lower the melting point and so on and so forth. So as soon as this heats up now, we'll give it a good coating of solder. Make sure that it's properly tinned to stop it oxidizing, and oxidizing is what you don't want on your soldering iron or your solder joint itself. Alright, so we'll leave that sit there now with its tinning. Okay, and what we'll do is we'll just demonstrate how to make a joint. Again, we'll clip our wires or strip our wires. Now, when you're joining wires together, if they're of the same size, you can do it two ways. Number one, you can splay the wires out, put them together and then twist them, and that provides quite a good mechanical bond. If the wires are of different sizes, that's difficult to do, but if you are soldering wires or connecting wires of different sizes like that, make sure that the big wire bends properly and that you just don't have the smaller wire coiled up around the big wire. So you have to make sure that both wires are twirled, so to speak, and you make sure that they're all included in it. Now that we have our two wires twisted together, what we can do is sort of attach them up to this little device. This is called a pair of magic hands or something like that. And effectively what it is just a set of crocodile clips to be able to hold the wire together for you whilst you put the soldering iron underneath, heat the joint and then feed solder into the joint itself. Okay. Now, generally they come with a little stand. All I've done as well is I've bolted on a small magnet or a small ring magnet that allows it clamp onto a trailer frame or whatever I'm working on. Right, we'll clean off our soldering iron. So that's ready to go. And what we do then is we heat the joint. And obviously this is one of those occasions where a steady hand is of big benefit. Now I'll just bring you in a little bit closer there if I can. And what we're looking for here is that you can probably see the shapes of the wires, and then the solder itself has wicked down in between the wires and formed a sort of a mechanical bond. And what it does is it seeps into the microscopic pores of the wire and attaches then when it freezes. Most wires these days as well will come with some type of cleaning agent in them. Generally speaking, it's rosin with some type of halide activating, and what it does is it takes off some of the oxidation on the wire, because obviously copper corrodes in the environment, and you'll often see it going green. And it helps, number one, clean the copper wire, and secondly, it helps the solder flow into the joint as well. So at this point now, our joint is good, strong joint. What we do there, if we were in an automotive application, is we would have our heat shrink tube on already. Don't need to do it here obviously because we have an open-ended wire. We'd slide the heat shrink tube over the joint like that, and right, there we have now solder connection with a heat shrink wrap on it. Good weatherproof connection, good electrical conductivity, and one of the big advantages of solder joints is that you can join a big wire to a small wire, no problem at all. Okay. Right, that's roughly a sort of an introduction to the various methodologies of connecting wires. Again, it's a good life skill to have. This is not meant to be exhaustive by any means, but it can certainly indicate to you that there's different ways of joining wires, different strengths, different mechanical properties, different areas of application, so to speak. So if you have any questions, stick them in the comments down below, and I'll do my best to answer them. Other than that, thanks for watching.